What's up, gamers? This chemistry presentation is overdue, so let's just jump right into it. Chemical element review. Gold. I really don't want to do this. Maybe I should actually write a script. That'd be good. We can't get through a chemistry presentation without talking about some really boring stuff. So, let's... Boring in front of your chemistry teacher. Bonding and properties. And stuff. Gold is a metal, meaning it undergoes metallic bonding to find its structure. Metallic bonding implies a lattice of positively charged cations with a sea of delocalized electrons. Due to this structure, it conducts electricity, doesn't tarnish, is easy to work, ductile, malleable, can ally with many other metals, can be melted and cast into highly detailed shapes, has a nice color, and has luster. Let's go through each of those in more detail. Gold conducts electricity because of its free-moving particles, or the sea of delocalized electrons. Since they're delocalized, they're out of their shells, meaning they can move around freely and carry charge from one place to another. The same can be said about gold's ability to conduct heat. Since these particles are free-moving, they can bump into each other a lot to transfer the kinetic energy that eventually makes up heat. The free-moving electrons also explain the luster of gold. Since they move around a lot, they can reflect light, making gold shine. Gold is ductile and malleable because the cations don't repel each other, as they are still attracted to the sea of delocalized electrons even when force is applied and they're moved across over each other. Gold doesn't tarnish as it is highly unreactive. So I got this entire section wrong. Apparently, since the outer shell electron, so much force is applied to it from the heavy nucleus, it has to travel at speeds nearing the speed of light to prevent it from falling into the nucleus. This gives the orbital mass as a consequence, and so the orbit contracts since it has mass and it's attracted more to the nucleus. Since it's contracted, it's more tightly bound to the nucleus and less available for other atoms to bond with it. Yeah. Band theory basically suggests that when all these cations are together, their shells. Band theory basically suggests that when all these cations are together, their shells overlap, making it easy for electrons to move to higher energy levels. Once at higher energy levels, they can release more energy and cause more light to spill out. The properties of gold and its bonding basically make it so, according to band theory, the bands that overlap and the ones that release energy are less efficient at higher energy levels, since there can only be a few electrons in those valence shells. Gold only. I was also wrong here. Gold absorbs more blue light when its 5D orbital electrons go to the 6s orbital, because the distance is smaller in gold than other metals because of the whole mass thing and that stuff happening, I think. Gold has relatively high melting and boiling point, like all metals, because of the strong electrostatic attraction between its lattice and a sea of delocalized electrons. Sea of delocalized electrons, sea of delocalized electrons, sea of delocalized... That was painful! Let's move on. Dude, I seriously have like 2 pages of uses here. I guess I'll go through all of them. Because of gold's specific properties, it makes it a very good material for a lot of things. For example, something that you probably expect from gold, a lot of it is used in jewelry. 78% of gold consumed a year is used for jewelry. Because of its high luster, desirable color, tarnish resistance, ductility, malleability, and castability, it is a good metal for making jewelry. It's beautiful and easy to work with. It's also heavily embedded in tradition to use gold for very high status things. It's generally too soft to work with when applying jewelry techniques. So it's usually alloyed with copper, silver, platinum, etc. to increase its durability. Caratage denotes gold content in alloy. 24K is pure gold, 12K is half gold by weight, etc. Generally, high carat is softer and more resistant to tarnish, and low carat is stronger but less resistant. Generally, high carat is softer and more resistant to tarnish, while low carat is stronger and less resistant, especially to perspiration. Alloys are different colors, as shown by this diagram that I'm totally gonna put in afterwards. Over 6,000 years ago, transactions were done with gold. Gold or silver pieces were used as just currency in general. Its rarity, usefulness, and desirability gave it long-term value. So it was real stuff, basically, unlike the fabrication that is money these days. Gold could actually be used for something, so it was a worthy investment to trade for. It had high value, was durable, and was easily divisible. Between the transition of using gold and trading for items to modern money systems like notes that we have these days, gold was used as insurance to back up real money. Nowadays, gold investments are still held by government, people, and institutions in bullions, which are basically just bars. Low voltage and current is used in electronics, meaning it's easily interrupted by corrosion or tarnish at contact points. Since gold is an efficient conductor, can carry tiny currents, and remains free of corrosion, it is a reliable thing to use in electronics. Connectors, switches, relay contacts, solder joints, connecting wires, and connection strips are made with gold. Gold can be found in cell phones, calculators, personal assistants, global positioning systems, and other small electronic devices. Most large electronic appliances like TVs also contain gold. It is estimated that 50 cents of gold is in every cell phone. Nearly 1 billion cell phones are made a year, meaning lots of recycled gold. Computers require rapid and accurate transmission through the computer and from one computer to another. This means it requires an efficient and reliable conductor. Gold meets those requirements, justifying its high cost. I'm actually still drinking that coffee right now while I edit this. Man, it's taking ages. There's evidence to support the fact that as early as 700 BC, Etruscan dentists used gold wire to fasten replacement teeth into the mouths of their patients. Gold is chemically inert, non-allergenic, and easy to work, meaning it can be used for fillings, crowns, bridges, and other orthodontics. It also has an aesthetic appeal and tarnish tolerance, though I don't think you'll be finding too many people with golden teeth these days. Gold is used in drugs for some medical conditions. Sodium orothiomalate or orotheoglucose is used to treat rheumatoid arthritis. Radioactive gold isotopes are also used for radiation sources to treat certain cancers. By implanting small amounts of gold into the upper eyelid, lagophthalmus, a condition where you can't close your eyes completely, can be treated. Radioactive gold is also used in medical diagnosis. It is injected in a colloidal solution, which is microscopically dispersed in soluble particles suspended throughout another substance, and tracked as a beta radiation emitter as it passes through the body. Colloidal gold is also used in pregnancy tests as the red marker. Surgical equipment and life support also use small amounts of gold. It is non-reactive in the instruments and highly reliable in electronic equipment and life support. As the possibility of lubricating, maintaining, and repairing things is zero, as they're floating through freaking space, extremely dependable materials are essential. As previously discussed, gold is used in circuitry as it is a dependable conductor and connector. Gold-coated polyester film, which reflects infrared radiation, helps stabilize the temperature in space. Gold-coated polyester film is used to reflect infrared radiation and help stabilize the temperature of the spacecraft, preventing dark-colored parts of the ship from absorbing significant heat. Gold is also used as a lubricant between mechanical parts, as organic lubricants would volatilize, explode, broken down by intense radiation beyond the atmosphere. It also has a low shear strength, meaning thin films of gold between important moving parts can lubricate them. Gold molecules slip past one another under friction provides lubricant action. Sure. Metal of highest esteem and status. That's what I have written. I guess that makes sense. It also It also represents purity, so it's used for religious stuff like crosses, communion ware, other symbols. Represents first place in things like Olympics, Academy Award, Oscars, Grammys, whatever. I'm getting sick of listing all the uses of gold because it has so many that I don't really care about! Glass making! As a pigment, small amounts suspended when glass is annealed produce a rich ruby color. Gold also climate controls buildings and cases. Small amounts of gold dispersed in glass or coated on surface reflect solar radiation to make things cool in summer, and reflect internal heat inwards, warming it in winter. Visors on astronaut helmets also have very thin films of gold, which reflect much of the very intense solar radiation of space, protecting eyes and skin. Gold has the highest malleability of any metal, enabling it to be beaten into sheets few millionths of an inch, 2.54 centimeters, thick. These sheets are known as gold leaf and are applied over the irregular surfaces of picture frames, molding, or furniture. It is also used internally and externally on buildings, as it is a durable, corrosion-resistant cover. One of its more prominent looking things on buildings is probably the domes of religious buildings and other important structures. The cost is very high per square foot. Finally! Next question! Ethics. Wait, no, life cycle. Gold is mined. In small-scale mining, gold is found as particles in loose sediment. These are mostly artisan operations, as in just people who want to make stuff from the gold they found. Techniques such as panning, which is the oldest gold mine method, are used. It's cheap, simple, and easy, and you separate heavy gold with a sluice box, which is like a slide sieve. Slide sieve. That way, slide sieve. Or a dry washer, which is like an air sieve. Large-scale or hard rock mining produces most of the world's gold. It is done when gold is encased in rock. Open pit mining is used if rocks or minerals are close to the surface. Underground mining is where ore is extracted through tunnels or shafts. Hey. What's up? Yeah. Nah, it's fine. Yeah, I can edit it later. Yeah. Or I'll just keep myself looking at you awkwardly while I whisper into the microphone. Cause I'm bored, damn it! Processing! Gold is from the earth, so it can be found in places like mountain caves and riverbanks. Or is crushed and ground to finer particles. It then goes through a process called leaching, which is where the gold is dissolved with a cyanide solution to separate it from rocks. Modern cyanide mills recover 95 to 98% of gold in the ore. That's the formula! It's one of the only formulas I could find for gold processing. Please don't kill me, Mrs. K. Because I'm already dying doing this. Oxygen removes one electron from each gold to form that ion. Adsorption is next. Adsorption is the adhesion of atoms, ions, or molecules from a gas, liquid, or dissolved solid, which is what ours is, to the surface of another substance. In this case, gold is put on activated carbon. It then goes through the process of elution, which is basically just reverse adsorption to get the gold out of the absorbed material. The end of this process of separating gold from the ore is electrowinning, which is passing a current through the solution to make gold ions move to a cathode and form a solid compound around that cathode. Electrode, cathode. Yeah. Going back to the beginning of this, so before leaching, there's another process that can go through, which is just decanting, precipitation, and filtering. It's just separating the mixtures from the immiscible liquids, waiting for the sediments to precipitate. Sediments or precipitates to settle, then pouring the rest of it out. In precipitation, SMB, or sodium metabisulfite, is added and the gold precipitates out of the solution. And then you can just pour it out, pretty much. Bringing all those together, from both processes, after this this gold is extracted and made more pure, pretty much. The gold is then caked, all the particles are put together, and it's smelted, which is means it's heated to the melting point to get rid of impurities, and then it's casted into bullions, or bars. And then the expected final part of its life cycle is the commercialization of gold. Gold is sold for investment reasons after being sent to the assay office, or sold in jewelry for industrial uses, or to electronic contractors. Then it's just bought, pretty much. You can order it online, you can buy it from your bank to invest, I guess. Then some of the gold, not all of it, is resent and recycled, which usually happens in electronic parts. You see when you chuck your phone, and that whole thing where there's more gold in a mobile phone than there is in gold ore. Citation needed. Last question! Ethical stuff! Gold has ravaged landscapes, contaminated water supplies, and destroyed vital ecosystems. And we're still mining it! Cyanide, mercury, and other bad stuff is regularly released. Mercury is used to recover small amounts of gold in soil by combining with it. About 20 tons of toxic waste are made. About 20 tons of toxic waste. About 20 tons of toxic waste is made for every 0.333 ounce or 9.5 gram ring. Waste is usually dumped directly into natural water bodies. In 2014, for example, a dam collapsed in Mount Polley gold and copper mine in British Columbia, sending 25 million cubic meters of waste, mostly containing cyanide, to nearby rivers and lakes. That's about 9,800 Olympic-sized swimming pools, or about 11 MCGs. Yay, we're screwing the environment. It couldn't get much worse, could it? Well, in the Madre de Dios region of Peru, there's been evidence of child and juvenile labor, serious health and safety risks, sexual trafficking, workers forced to work at gunpoint. Through long-term exposure, miners are also likely to develop silicosis, silcotuberculosis, pulmonary tuberculosis, obstructive airway disease, occupational asthma, oral and or nasal cavity erosions, diseases owing to ionizing radiation, noise-induced hearing loss, and whole body and hand-arm vibration syndrome, as well as repetitive strain injuries. I have no good way to end this.